In this video, we're going to be dividing rational expressions. It's as easy as 1, 2, 3, 4. So we're going to first factor, then flip, simplify, and then find what x is not allowed to be. So it's very similar to multiplying, except for our flip step. Then there's also going to be a little something different down here with our finding what x is not allowed to be. So we're going to start off by factoring our first numerator. As we look at this, we have an x to the third, which is a perfect cube, and we have an 8, which is also a perfect cube. And because we have a minus sign, means that we have the difference of cubes. So this should be pretty easy to factor once we take the cubed root of x to the third and the cubed root of x. So that first factor is going to end up being x minus 2 times x squared plus 2x plus 4. And now we're ready to factor our denominator. Here we have a x squared minus a 4, and x squared is a perfect square, and 4 is a perfect square. And because we have the minus sign there, we can take the difference of squares here. So if we take the square root of both sides, we'll see we'll have an x minus 2 and an x plus 2 from this. So x minus 2 and then an x plus 2. So now we can factor our numerator on our other fraction. And here we have a trinomial with the 1 as a leading coefficient. And so we can factor this going what two numbers will multiply to 4 and yet add to 2. And that's a pretty easy one because there's nothing that will multiply to 4 and add to 2, which means that this is already completely factored. So I'm just going to rewrite it so that we don't get lost. All right, and then we need to factor our denominator from the second fraction. So this one looks a lot like the numerator from our first fraction, except it has a plus sign. So we can use this as the sum of cubes. So when we take the cube roots, we again end up with an x and with a 2. And we'll use our sum of cubes to write our factor here. So let's go ahead and just write this down. And by this I mean our second fraction. And so we've got the sum of cubes here, plus 2, x squared minus 2x plus 4. So we've completed the first step and ready for our second step where we need to flip. The flipping takes place on only the second fraction. When we're normally dividing a fraction and another fraction, it's keep, change, flip. So we'll keep the first fraction, change our division sign to multiplication, and then flip that second fraction. So that's what we're going to do now. So here we have our keep, now we have our change, and now we have our flip. So now we have the second step finished, and now we're ready to simplify. So we're going to be looking to find pieces that are the same. So really quick, I want to point out that everything inside of parentheses is its own family or group, and it can't be separated or pulled apart. In the denominator on our second fraction, written in blue, we have x squared plus 2x plus 4. Now because they have plus signs between them, that connects these. If it had just been multiplication signs, they'd be their own individual pieces. But because they have plus and minus signs, making them their own polynomial, they stay as one whole group together. So as we look in our numerators and our denominators, I see that there's an x minus 2 that they have in common, and an x plus 2 that they have in common, and an x squared plus 2x plus 4 that they have in common. So we were able to cross a lot off this time. So we're now ready to write what's left over. So our leftover piece is the x squared minus 2x plus 4, but we still have to write down all of the things that x is not allowed to equal. So remember, that means that we need to take everything that's in the denominators that we crossed off, and we need to set those equal to 0. And because we started off with the second fraction being flipped, technically anything in the entire second fraction that got flipped out or crossed out is fair game and needs to be written down. So we crossed off x minus 2, so we'll set that equal to 0. We crossed off x plus 2, so we'll set that equal to 0. Now in the second fraction, we've already written down x plus 2 from up here on the top, so we don't need to write that down again. But we do need to write down our x squared plus 2x plus 4, because we still need to solve that for 0. So here we're going to get that x can't equal 2 and x can't equal negative 2. Now, to find what x can't equal in our last equation, because we can't factor it, we're going to need to use the quadratic equation to solve this problem. Or we can complete the square. So we're going to complete the square because it's going to be a little bit faster for this problem. So to do that, we need to move the 4 over to the other side and leave a space. We're going to have x squared plus 2x plus, we're going to leave a space, equals negative 4, because we just moved our 4 over to the other side. And then we have to actually put plus leave a space. Now this plus leave a space is what helps us to complete our square. So now what we're going to do is we're going to take our middle number, the 2, and we're going to divide that 2 by 2, which gives us a 1. Then we're going to square that 1, and that answer is what we're going to write in our leave a space. So we're going to put plus 1 here and put plus 1 there. Now because we're doing what's called completing the square, what that means is that we're going to take our x and we're going to put a answer next to it, plus or minus. So it's all about what this middle number right here was. That was a positive 1. So we're going to have plus 1. And then we're going to square that because we had to square it over here. Then we're going to set that equal to what this side right here, this right-hand side, equaled. And negative 4 plus 1 is negative 3. So then, if we try and solve x plus 1 quantity squared equals negative 3, our first step would be to square root both sides. But we know that if we try and square root that negative 3, we're going to get an imaginary answer, a no real solution. And for right now, we don't have to write that number down as one of the things that x is not allowed to be. That's not always going to be the case. Many times when you have a polynomial like this, it will come out to something that you can work with. So you need to be careful and make sure that you did everything you were supposed to. So as we go back to that last step, what are all the things that x is not allowed to be? The answer is just x cannot be a 2 and x cannot be a negative 2. And now we have our solution.